This section addresses the potential hazards that may occur within the laboratory environment. It is essential for individuals conducting experiments to be aware of these risks and take appropriate precautions in order to minimize the likelihood of accidents. Definitions of hazard types, hazards, and risks. Types of hazards refer to anything that has the potential to cause harm or damage. These are considered potential hazards that laboratory personnel may encounter, and they are often associated with various risks in laboratory settings. Hazard is defined as a source of potential harm or damage. It refers to any factor or condition that has the capacity to cause injury, illness, property damage, or negative impacts on the environment. Risk refers to the possibility of an undesirable event occurring within the laboratory. In this context, risk involves uncertainty regarding the outcomes or consequences of laboratory activities, which may affect personnel, physical assets, or the environment, elements that are considered valuable and should be protected. Within the laboratory, hazards are categorized into 4 main types as follows. 1. Chemical hazards. Chemicals may have reactive, flammable, toxic, and corrosive properties, which can affect physical safety, health, and the environment. 2. Biological hazards. These arise from biological experiments involving microorganisms, biological agents, and animal toxins. 3. Electrical hazards, originating from scientific equipment, including electric shocks, sparks, and the unsafe use of extension cords, which pose risks of electrocution to laboratory personnel. 4. Physical hazards, exposure to noise levels exceeding 85 decibels, slips, trips and falls, contact with hot surfaces, and injuries caused by being crushed or pinched by equipment. Chemical hazard, a non-biological substance that has the potential to cause harm to life or health. Chemicals are widely used in the laboratory and in many other places. Exposure to chemicals can cause acute or long-term detrimental health effects. There are many types of hazardous chemicals, including neurotoxins, immune agents, dermatologic agents, carcinogens, reproductive toxins, systemic toxins, asthmagens, pneumoconiotic agents, and sensitizers. Biological hazard. A biological hazard is caused by biological waste, such as medical waste, microorganisms, viruses, etc. The biological hazards can affect both human and animal life and health in a variety of ways. Electrical hazard, a dangerous condition such that contact or equipment failure can result in electric shock, arc flash burn, thermoburn, or blast. Physical hazard, an agent, factor, or circumstance that can cause harm with contact. They can be classified as type of occupational hazard or environmental hazard. Physical hazards include ergonomic hazards, radiation, heat and cold stress, vibration hazards, and noise hazards. Safety sign. Type of sign designed to warn of hazards, indicate mandatory actions or required use of personal protective equipment, prohibit actions or objects, identify the location of firefighting or safety equipment, or marking of exit routes. Safety signs are categorized into 5 main types. Circle with white background and red border/diagonal line indicates prohibition or stop actions, such as no smoking, no entry without authorization, etc. 2. Circle with blue background indicates mandatory actions, such as wear protective clothing, wear safety glasses, etc. 3. Triangle with yellow background and black border indicates a warning of danger, such as chemical hazard, sharp object hazard, etc. 4. Rectangle or square with green background. Indicates safe conditions such as emergency exit, emergency eye wash station, etc. 5. Rectangle or square with red background. Indicates firefighting equipment such as fire extinguisher, fire alarm, etc. Safety information sign. 1. Prohibition sign. 2. Mandatory sign. 3. Warning sign. 4. Information about safe condition sign. 5. Fire safety sign. GHS pictograms. Globally harmonized system of classification and labeling of chemicals. GHS pictograms are internationally standardized symbols used to identify the hazards associated with chemicals. These symbols help communicate the nature of chemical dangers, such as flammability, corrosiveness, or toxicity, so that people can handle and store them safely. There are 9 core pictograms representing hazards to physical health, human health, and the environment. GHS-01, explosive, indicates explosive substances and mixtures. GHS-02, flammable, indicates flammable gases, aerosols, liquids, or solids. GHS-03, oxidizing, indicates oxidizing agents that may cause or intensify fire. GHS-04, gas under pressure, indicates gases stored under pressure, including compressed, liquefied, or dissolved gases. GHS-05, corrosive, indicates substances that can cause skin corrosion or burns or serious eye damage. GHS-06, acute toxicity, severe, indicates chemicals that can cause serious toxic effects or death even at low doses. GHS-07, acute toxicity, harmful, indicates less severe toxic effects such as skin irritation, eye irritation, or respiratory issues. GHS-8, health hazard, indicates long-term health effects such as carcinogenicity, reproductive toxicity, or organ damage. GHS-09, environmental hazard, indicates substances harmful to the aquatic environment. Safety Data Sheet, SDS, also known as Material Safety Data Sheet, MSDS. An SDS provides essential information related to chemicals and products to help users and stakeholders understand the hazards, protective measures, and safe handling practices. The SDS typically follows a standardized 16-section format under the GHS system, with each section containing crucial safety and handling details. Main components of the SDS. 1. Identification of the substance or mixture and of the supplier. Chemical name, trade name, manufacturer, supplier, address, phone number, and emergency contact information. 2. Hazard identification. Classification of hazards according to GHS, hazard pictograms, precautionary statements, and warning caution messages. 3. Composition/information on ingredients. Details of individual chemical components, their concentrations, and other relevant data. 4. First aid measures. Initial first aid instructions for exposure through skin, eyes, inhalation, or ingestion. 5. Firefighting measures. Suitable extinguishing methods, recommended extinguishing agents, and required protective equipment. 6. Accidental release measures. Procedures for containment, cleanup, and proper disposal of chemical spills. 7. Handling and storage. Guidelines for safe handling, storage conditions, and transportation precautions. 8. Exposure controls/personal protection. Exposure limit values, personal protective equipment, and related safety measures. 9. Physical and chemical properties. Physical appearance, e.g. color, odor, boiling/melting point, and chemical properties, e.g. solubility, pH, 10. Stability and reactivity, chemical stability, incompatible substances, and potential hazardous reactions. 11. Toxicological information, toxicity data, health effects, routes of exposure, and relevant toxicological details. 12. Ecological information, environmental impact, aquatic toxicity, and other ecological considerations. 13. Disposal considerations, proper methods for chemical disposal, waste handling, and regulatory compliance. 14. Transport information, regulations and classifications for the transportation of hazardous substances. 15. Regulatory information, applicable chemical laws, safety regulations, and compliance information. 16. Other information, any additional details the manufacturer or supplier wishes to include. As shown, this is the Safety Data Sheet SDS for mercury. Next, safety guidelines for laboratory users, students, lecturers, researchers. To ensure laboratory safety, all users must strictly follow the guidelines. The following are key safety topics for students, lecturers, and researchers. 1. Dress appropriately by following the dress code for entering the laboratory of the Scientific and Technological Instrument Center for students, SG05. 2. Laboratory users must study the safety manual, equipment usage manuals, chemical safety data sheets, SDS, and be familiar with the locations of emergency equipment before beginning work. 3. If you have a chronic illness or are feeling unwell, inform a lecturer or staff member. In the event of experiencing symptoms such as dizziness, lightheadedness, headache, fever, or abdominal pain, the individual must promptly notify the supervising lecturer or laboratory personnel. Those with pre-existing medical conditions are advised to take their prescribed medications regularly to ensure their health and safety while in the laboratory. 4. Do not bring or consume any food or drinks in the laboratory. Also, do not store food in refrigerators used for samples, chemicals, or microorganisms. The consumption or storage of food and beverages within the laboratory may pose a hazard, as it can lead to the ingestion of chemicals or microorganisms through direct or indirect exposure. 5. Do not apply makeup or use cosmetics in the laboratory unless they are part of the experiment. 6. Smoking is strictly prohibited in the laboratory and surrounding areas. 7. Do not engage in horseplay or disturb others while working in the laboratory. 8. Keep the work area clean and organized. Do not obstruct walkways, especially entry/exit paths and access to electrical panels, fire alarms, or life-saving equipment. 9. Do not wear lab coats or gloves outside of laboratory work areas. 10. In case of an accident or unusual event, immediately inform the supervising lecturer or laboratory staff. 11. Dispose of experimental chemicals only in designated containers provided by laboratory staff. Never pour chemicals into sinks. 12. All chemical containers must be clearly labeled. Labels can be obtained from the laboratory staff. 13. Laboratory users must wear appropriate personal protective equipment, PPE, suitable for the experiment. 14. After completing your work, check all equipment, electrical systems, gas systems, and clean the area thoroughly before leaving the laboratory. 15. Whether during or outside of official working hours, all laboratory users are required to adhere to the buddy system principle. This means that a minimum of 2 individuals, including the person performing the task, must be present at all times during laboratory operations. The accompanying individual must also be authorized to perform duties within the laboratory. The topics of personal protective equipment. PPE refers to the equipment worn by workers during their tasks to protect against potential hazards in the work environment. PPE types can be categorized based on the part of the body they protect. There are 7 categories based on the type of protective equipment used for each part of the body: head protection, face and eye protection, hand protection, foot protection, body protection, hearing protection, and respiratory protection. Head protection. Safety helmets, used to protect the head from impacts or falling objects during work. Hair covers made of synthetic fibers, used to cover the hair and head to prevent hair from falling out and to protect against contamination. Face and eye protection. These items protect against hazards such as chemical splashes, debris, or radiation that could damage the eyes. Safety glasses. Protect the eyes from contaminants, chemicals, or small dust particles. Face shields and masks attached to safety helmets. Protect the face and eyes from dust, chemicals, impact, debris from machinery, and welding light. Hand protection. Hand protection is used to prevent injuries to the fingers, hands, and arms during tasks. There are different types of gloves suitable for specific tasks. Chemical-resistant gloves, made from natural rubber, nitrile, PVA, or PVC. Thermal protection gloves. These are divided into 2 types: gloves for heat protection and gloves for cold protection, including those used for handling liquid nitrogen. Cotton gloves, used for low-risk tasks. Foot protection. Footwear is used to protect against hazards in areas with risks such as slippery floors, electrical hazards, or chemical exposures. Approved footwear for laboratory use includes safety shoes, safety boots, closed-toe footwear. Body protection. Protective clothing is worn to safeguard against hazards in the work environment, such as chemical splashes. Lab coats, worn over normal clothes during tasks. The lab coat should be fastened properly, and it should be selected to fit the wearer. Precaution. Always remove the lab coat before leaving the laboratory to prevent contamination. Chemical splash aprons, worn over the lab coat to prevent chemical splashes. Protective suits for material debris, worn when working with machinery or tools such as cutting, drilling, or welding equipment to prevent debris or sparks from causing injury. Hearing protection. These devices protect the ears when working in areas with high noise levels for extended periods, common in industries, machine operations, or construction work. Common hearing protection includes earplugs and earmuffs. Respiratory protection. Respiratory protection devices are divided into 3 types. Medical masks can filter particles as small as 5 microns, typically used in healthcare settings to prevent infection. Dust masks, such as N95 masks, which filter particles as small as 0.3 microns. These require fit testing for optimal performance. Full face masks. These cover the entire face to protect against dust and microorganisms with small particles. General guidelines. Wear PPE when in the laboratory or work area. Always remove PPE before leaving the laboratory or work area. Choose appropriate PPE for the specific tasks being performed. Thank you for your attention.